Hey there, Emmanuel here from WebDevFuel, and in this video, I want to share with you a special technique that I've uncovered with GPT-5 and Cursor. So I'm currently trying out Cursor, and I'm actually enjoying it a lot more than previously. Not really sure if that is because of the GPT-5 model. Maybe that's part of the reason, but also the UI is much more improved, and I'm trying to get a feel for it since I'm usually more in Vim, so I have a lot of like keyboard driven workflows. So it's a bit different for me, but I'm still getting used to it, and I really like how I'm able to like do all of the agentic coding with it. And I'm still using NeoVim when I want to get more into the code and do things where I manually need to mess with stuff. So like I said, in this video, I want to share with you a technique that I'm using with GPT-5 that's working really well. One of the benefits of this model, at least in my opinion, is that it follows guidance and it follows instructions very closely. So while Claude is very good at being creative and at like exploring things, most of the time I don't want the model to do that, and I would get very frustrated when I would give a task to Claude, either Claude Sonnet or Claude Opus, and it would start wanting to be creative and reinvent the wheel and do a lot of what I call side quests. So you give it like a task and it says, oh, but I also discovered that there's a problem here, so let's fix it. And I've also discovered that there's a problem in the other side, so let's also fix that. So I've essentially realized that it was not necessarily a problem with all models, but more with this Sonnet and Opus models, the Claude models. But with GPT-5, that problem does not exist. So that means that instead of me needing to be very specific as to what the model shouldn't do, I only need to instruct it what it's going to do, and it follows things very closely. Now, this means that if you are not good at web development, if you don't have experience with coding, it means that you will have maybe less success using GPT-5 because you're going to be like, okay, I don't know how to do this, please guide me. But what I find it's the strength of GPT-5 is that we are able to basically say, okay, I know exactly what I want to do. I know exactly like the structure of my code that I want to have. I know exactly what the end goal is, and I know what the architecture is. All of those things I already know what I want. I just want to like go faster. So that's basically the idea here. So as a result of this, I found out that it's one of the best things that we can do, and this is the core of this strategy that I'm about to share with you, is that we want to tell the model to test things along the way as it's building its features. So with Claude Sonnet and with Claude Opus, this was much harder to do. And honestly, I didn't even reach this conclusion with those models because, like I said, it usually tries to do so many things that I would be like, okay, I'm just going to leave the model by itself doing its own thing because it's going to be very, very hard for me to try to steer it into the direction that I want. So I would just end up uh, doing this thing where, for example, I wanted to build a calendar application, and I can show you here how it's looking so far. So we still have here a lot of things that are left over from the previous implementation, which is related to the strategy that I'm about to share with you. But with Sonnet, for example, I literally, and I'm not kidding, was able to like build the entire prototype in like 1 hour. Now, this is not to sell you on this dream of like AI builds my SaaS in 1 hour, because the application had a lot of errors. It was filled with bugs. It was filled with errors, and the reason for this is because Sonnet would try to, I don't really want to say one shot it because that was not really the thing that was happening, but Sonnet was trying to like do everything and like implement everything from scratch. And that's not what GPT-5 is good for. If you tell it, okay, look, I want to like build this web application that does this, this, and this, it's going to have not only a hard time implementing all those things, but it's not necessarily even going to try to implement all those things and all of those little details. Make sure that the UI is perfect and that everything is perfect on like the first try. Now, I haven't necessarily tried to give it like a big prompt and try to one-shot things, but I'm not really sure even if that's the correct way of doing things, because if we do that, then we're sort of in this cycle of, okay, I've built this massive prompt. I want it to one-shot things or to build things in like one or two prompts, and then you see, okay, so it did hear something in this part of the application that I don't want it to be that way. So then you need to go back and rerun everything. So it just becomes like a very hard process to deal with. So what I've discovered that it's best at this model is just giving it small tasks and trying to sort of incrementally build things along the way. So if I show you here this, so I'm building this calendar web application that's going to be geared towards like using AI to fill the schedule for mostly for people with ADHD, but also for other people, mostly for work purposes. So as you can see, I've basically created here also with the help of GPT-5, here the criteria and all of the tasks that we need to build here, like the real calendar UI with the ND foundation. Then we have here the mutations, and then we have here the full screen calendar plus the collapsible sidebar. And then we have the constraints aware auto scheduler. Now, if I'm not really sure if I still have that thing here. So I had like a roadmap um, here implemented, and I'm not really sure if I can even see like uh, when I had this here, but basically I had this version of this exact same file at the beginning with all of the steps necessary to create this, um, but completely from scratch. So I first of all started by creating all of the convex actions, all of the stuff that we need there. So before, just a few prompts before recording this video, I had here like a form to complete like the events and to also complete like the details for a new task. And I decided to basically say, okay, so I have like this skeleton app that I've built, and now I want to only build like the first steps of the thing that I want to accomplish. So now I first need to like make sure that the mutations work correctly, that we can actually see the data, see the events coming from convex. And then I want to build, okay, the next step. The next step is going to be a calendar that I can like drag and drop around and move tasks inside of this calendar application. So now what's the next step? The next step is for me to maybe like clean this up and ensure that we have here a nice UI and that this popover actually allows me to change more details besides like the name. So as you can see, we have here a few bugs when it comes to this thing. So this is part actually of the thing that I'm building now. So what I want to show you here now, um, to maybe like make sure that this idea sticks with you, is this prompt that I gave it. It is very short, but it's very powerful. So the idea is that with GPT-5, you don't want to give it like a very big task to change a lot of things inside of your application, and you don't want it to be necessarily always outcome driven, but rather process driven. So what this means is that you want it to you want to give it as much details as possible, and you want to give it as much like opinions as possible in when it comes to like the way that you actually want to implement things. So I said here, for each part of the feature you implement, you should validate that it works atomically. Do not wait until the end of the entire task or feature is completed to validate. This ensures the implementation is valid and you can catch a bug easily along the way. So like I said, this ensures that we're able to build this feature in a much better way. And now, for example, the only mistake that I have here is that this is like dragging this and it's creating the events right away. So we can now prompt the LLM to fix this mistake, or I can even go back now and re-implement all of these things with more instructions here. So if I take a look here at this, I've said, so I've invoked here the task. So if I expand here, these are the tasks that I've selected from the roadmap. So I basically select this way, and then I do Command L, and it shows the items that I want to implement here. And then I simply pass the task, and since this is like selected, it knows that I want to do that. So after doing this, I provide like a small adjustment here based like a more context, let's say, when it comes to this particular task. And I might now go ahead and simply revert all of these changes, because as you can see, it is not a lot of changes. If I come here and see how much, so we've consumed here, as you can see, 24% of the total tokens. So this was not a long running task. This is not a task that takes like 1 hour, 2 hours to complete with some agents, or even like 20 minutes, 10 minutes to complete with one agent only, and then continuing with other agents. Instead, this is something very small. So I have here the calendar. I already have like the mutations working. I have everything working. And this means that I can essentially now only like work on this part of the task. And I'm basically able to like steer the model much easier, because I'm like, okay, this part of the application now works. I know that this works. So now let's move on to the next section, the next thing that we want to implement. And if you've already built web applications by yourself, you know that this is the process that you should be using, either way, even if you're using LLMs or GPT, or if you're building things yourself. So this process means that you can like test things. So if you think about how you as a human develop it, you're basically like saying, okay, I want to now create a popover. Let's just see if this popover actually opens. Okay, so now that it opens, I want to add in their information. Okay, let's see if I can save it. Okay, so now that the popover works for the create, let's also see if I can also edit something. So then if it breaks on the edit, it means that there's a problem there with the edit, or with the popover itself, and we can like adjust things accordingly and continue testing things. But the idea here is that, again, we want to atomically give actions to the LLM, and to help with these atomic like tasks that we want to give it, we want to tell it to like split even more the tasks by testing things along the way using the Playwright MCP server. So you should implement the tasks in small increments and validate that they work through the Playwright MCP server by spinning up the server on port 3000 with this command. And then for each part of the feature you implement, you basically validate that it works atomically, making things much, much easier. So this is it. This is the idea that I wanted to share with you. Like I said, I'm really enjoying playing with GPT-5. I'm by far liking it much, much more than Sonnet 4, than Opus 4. First of all, because of its price, it's much, much cheaper. Second of all, because it has much better integration here with Cursor, and we also have the Codex CLI, and Cursor is now also developing a CLI, which means that I can also like play around. So I'm doing something here a bit different. So I want to also like implement a fine tuning on a Quen model. So basically, I end up having like a small model that I can use to schedule these things using an AI. Uh, when I finish implementing this application, so that then this model can learn, okay, so based on these patterns of this user, I need to like schedule things this way based on like the energy levels of someone with ADHD, and stuff like that. So that's basically the idea of this app. And like I said, this is part of the reason that I'm choosing to use GPT-5, because it's helped me also with this stuff. And I can simply say here cursor agent. In this case, I need to pass here GPT-5. So for example, here the high is not working, so we need to choose one of these. So in this case, I can grab here the model GPT-5, and then I can start playing with it and asking it to do things. And this is one of the reasons that I'm enjoying GPT-5 a lot, because it integrates really tightly with Cursor. And in a sense, like Cursor is now leaps ahead of the competition, because it integrates so well with GPT-5. So yeah, I'm now just here rambling, but I'm going to make more videos in just a couple of days related to this, related to how maybe I'm using Cursor in particular, videos about how to like better prompt GPT-5, and different stuff when it comes to programming with LLMs. So if you want to see those things, let me know in the comments below, and also subscribe to be notified when I release those videos, and I'll see you on the next one.